Good afternoon, everybody. I'm David Arpin. I'm a data science manager with AWS's professional services team, and I'm very lucky to have with me today Prasad Prabhu, a principal engineer at Intuit on their data platform team. We're going to talk about build, training, and deploying machine learning models in SageMaker. So thank you guys for all joining us this afternoon in this afternoon run-up, last session of the day before replay. So we appreciate you diehards coming out and attending. What we're going to do today is give a brief view of Amazon SageMaker. We'll talk about each of the three components of build, train, and deploy. We'll talk about a little bit of the additional functionality we've built into Amazon SageMaker, so the customized algorithms, pre-built deep learning framework containers, the ability to bring your own Docker container algorithm, and SageMaker automatic model tuning. And then we'll dig into the kind of 400-level content that is real-time deployment at scale. So this is an area that we have a lot of customers using SageMaker successfully on, but it's also an area that we get questions from customers on how to do this better and more effectively. So we'll talk about creating and updating endpoints. We'll talk about reduced risk deployments and automatic scaling of SageMaker endpoints. Then I'll pass it off to Prasad, and he'll talk through how they're using SageMaker, add Intuit, integrating it with their data science workflows, and give an overview of their architecture that they've created. So let's start off by just talking about AWS's machine learning stack. So we really view machine learning as this three-tiered stack where AI services are at the top. AI services are very simple, easy-to-use, API-based ways that you can implement machine learning and artificial intelligence into your workflows. So whether that be computer vision, where you may be using recognition to do image classification or object detection, whether you're in the speech space, where you're using Poly for text-to-speech or transcribe to go the other way around, or you're doing language where you may use comprehend to analyze a large corpus of documents, or translate to convert from one language to another, or Lex to build your own chatbot. You can be assured that we have done the heavy lifting for you to train and set up these services so that all you have to do is bring your data and make a simple API call to get back results from machine learning and go very deep in these domains with a lot of expertise here. But a lot of times people have machine learning challenges that are outside of any of these domains. And that's why we've created that second layer, which is Amazon SageMaker, our machine learning platform that allows you to build and train your own machine learning models, whether they be in a domain that's outside of the ones of the AI services, or whether they be just a very customized version of something in the vision or speech or language domains. And then those are resting on the more foundational layer of ML frameworks and infrastructure. And it's AWS's goal to be the best place to run a variety of deep learning frameworks. So whether you're using TensorFlow, whether you're using MXNet, whether you're using PyTorch or Chainer, we want to be the best place to run those frameworks, the fastest place. And that requires us to optimize these frameworks for the specific hardware that AWS has. So whether that be the P3 GPU instances, latest version of CPU instances, the C5s, or FPGAs, we want to be able to optimize that so that you can be as effective as possible in using those deep learning frameworks. And for a long time, we heard that ML is really complicated for everyday developers. It's a very long cycle that involves multiple teams. It can be error-prone. There can be gaps. And it requires you to collect and prepare your training data. It requires you to pick a machine learning model or algorithm that you want to use. You have to set up and manage a training environment. Then you have to scale that out and train and tune at scale. And all of that requires a lot of work and a lot of iteration, a specialized skill set. And then even after you've trained the model, your job's not done. You typically hand it off to another team. Maybe a team of scientists is training the model. They're going to hand it off to a DevOps team that's going to go deploy that model into production. And once they have done that, even that can sometimes require rewriting the whole process. That can be error-prone. But once they've actually completed that, they're not done. They have to still manage and scale that production environment as the service grows and traffic grows. So that was really the driving force behind why we launched SageMaker and why we worked so hard on SageMaker. We really designed it to be a shared set of components that can be used by scientists, that can be used by developers to implement machine learning in production in a very efficient manner. And so we've designed it so that with one click or just a few lines of code, you can actually create production-grade training and deployment environments. We've designed it so that we have customized algorithms that in many cases are 10 times more performant than their other counterparts that you'd find in the marketplace. They're also, once you have those two things, you can deliver predictive insights faster, make better decisions, and build better experiences for your customers. So how does Amazon SageMaker try and simplify machine learning? Well, when we think about SageMaker, we think about the 3 modules or components of the service. And those are build, train, and deploy. So the first component is build. So SageMaker provides a very easy-to-use notebook instance experience. So you want to spin up an instance that's running a Jupyter Notebook server. Jupyter Notebook is a really interactive, easy way to visualize your data, explore your data, run snippets of code, document what you've done with Markdown. And it's a great interactive way that a lot of data scientists have come to experience and build machine learning models. But you don't have to use that. You're not locked into using Jupyter Notebooks. SageMaker is modular. These 3 modules can be used independently of one another. And so if you want to use just 1 or 2 of them, you can always just pick 1 or 2. And so if you don't want to use the Jupyter Notebook instances in SageMaker, you can always call those training and deployment APIs from your own device, whether that be a laptop, a EC2 instance, Cloud9, wherever it works for you. Now onto SageMaker training. We really tried to design this as a managed environment so that when you call a SageMaker create training API, it will spin up a provisioned separate training cluster of instances. It will load in an algorithm container. It will load data in from S3. It will train your algorithm, take any outputs, write them back to S3, and then tear down that cluster without you having to think about any of that, without you having to manage any of that. And of course, it works distributed settings, so you can spin up multiple instances at once and have them work together on training your model. And you can also take advantage of things like high-performance I/O. So pipe mode, which allows you to stream data directly from S3 into your training instances so that you can begin training immediately as soon as your instances are up and the algorithm is ready. Now on the deploy component, we've tried to provide a lot of options there as well. So real-time endpoints is what we'll talk more about later. But really, when you want to create a prediction from your model, you want to create this real-time endpoint that gives you a REST API so that you do an HTTP post request, get back a prediction in near real time from your machine learning model. You want that endpoint to be persistent so that you can build your service around it. You want it to be reliable and scalable. And that's what SageMaker real-time endpoints provide. You can also use batch transform. So if you have a large number of records that you need predictions for all at once in a batch setting, you can do that. You can use SageMaker batch transform. It spins up a separate batch transform environment. It streams data in from S3, generates those predictions, writes the results back out to S3, and then tears down that hardware. So everything, again, is managed for you so that you don't have to think about that. And of course, going to SageMaker's modularity, you can also deploy to something like an AWS Greengrass or DeepLens, or even your own on-premise service, because the model artifacts that you get out of SageMaker training are yours to keep and do with as you see fit. Some of the additional features that we've built for Amazon SageMaker include the SageMaker algorithms. And these are really designed for speed and scale. They've been rewritten with advancements in both science and engineering to take advantage of things like GPU acceleration and train in a distributed manner. And the science is different too. So that actual mathematical methodology that is used for them is different than what you would find in other implementations of these algorithms in many cases. And we have an eclectic mix. So we have some supervised learning algorithms that are very common, things like linear regression and classification, unsupervised, things like k-means and principal components. But we also have computer vision algorithms like image detection and or image classification and object detection. And also in the natural language processing space, so word-to-vec, sequence-to-sequence for neural machine translation, neural topic modeling. So we have this variety of different algorithms that you can use for your use case. We also have pre-built deep learning framework containers in SageMaker. And these were designed so that data scientists who want to work in TensorFlow or PyTorch or Chainer or MXNet and write their own neural network or write their own algorithm are able to do so in a very natural way. They bring their 20 lines of Python or the Python that they would normally write in that framework, and they can send it to SageMaker without having to think about orchestrating containers or managing the building of that container. We've set up a process for them to do that. So that's very easy to write your code locally and send it to SageMaker and have it work in SageMaker's managed production-grade training and deployment environments. These are also open sourced, so if you wanted to make changes, if you want to use what SageMaker's built as a starting point, add additional libraries or functionality, you can do that as well. And because they're open sourced, you can use local mode and pull them locally onto your own environment, iterate very, very rapidly, and ensure that whatever you write locally is going to work when you push it to the larger scale in your production environments. And of course, SageMaker always provides the capability to bring your own. So if you have an algorithm that uses a library or a language like R or Java or Julia, and you want that to still take advantage of SageMaker training, and you can absolutely do that. You can just take that container, or take that algorithm code, bundle it up into a Docker container, and publish that to an ECR registry, and still use it in Amazon SageMaker. SageMaker also comes with automatic model tuning, and hyperparameters are very important to machine learning models in getting the right fits, getting the right performance out of your algorithm. And it's a lot of undifferentiated heavy lifting for a pretty specialized skill set in a lot of cases. Data scientists spend a lot of time iterating over to find the right hyperparameter values, and it's costly, it's expensive, and we wanted to make a very efficient way of finding the right hyperparameter values. So whether you're trying to tune the number of layers in your neural network or a regularization coefficient in a linear regression, you can use this automatic model tuning to do so. It's going to actually build a meta model, another machine learning model, on top of your algorithm, and it's going to try and predict where good hyperparameter values are, and then explore that hyperparameter space, and when it finds good values, exploit and really search tightly within that space where it thinks it's good. And this is great because it works really flexibly. It works with the SageMaker pre-built algorithms. It works with the deep learning framework containers. And it works with bring your own. So now let's talk a little bit about real-time deployments at scale. And as I mentioned before, this is an area where we see a lot of customers using SageMaker very successfully, but we also wanted to provide some good practices that others could benefit from. So the goal of SageMaker is that it makes it so easy to set up a real-time endpoint that has a REST API where you can HTTP post request, get back a prediction from your machine learning model. And that's single click or a couple lines of code. And these endpoints are really scalable, they're high throughput, and they're highly reliable. So you can be confident that you can build your service around them. So let's go through and see what actually creating an endpoint looks like. We've got AWS CLI code here. You could use the Java SDK or Boto 3 in Python to do the same thing. But in this case, we'll just use the AWS CLI and show you how easy it is to create a SageMaker endpoint. So after we've trained our model, we can now kick off the create model process. So we've trained our model in SageMaker. We're going to run AWS SageMaker create model. We're going to give it a model name. We'll just call it model 1 in this case. We're going to point it to an image. This image is a container living in ECR. And it has logic that can load in the model that we've trained and generate a prediction. And that's all you need to have really set up into this container. And then we point it to a path in S3, and that S3 path is where our model artifact is living. That could have come out of SageMaker's training, or we could have trained independently of SageMaker and put the model artifact in S3 as well. And we'll call that model artifact model1.tar.gz. Right? And then the other thing we'll pass in is an IAM role, which will give us permission to access that model artifact in S3 and create the SageMaker resources. So now that we've registered this model to be hosted in SageMaker, we can go ahead and create an endpoint configuration with AWS SageMaker create endpoint config. And this endpoint config, most importantly, points back at model 1. and says that's the model that we want to host with our endpoint. It also provides information like the hardware setup, so how many instances we're going to use and what type of instances we're going to use. In this case, 2 ML/M4X large instances. We have variant weight and variant name. We'll show how those are used in more detail later. And we'll give that endpoint config a name called model1 config. Now we actually want to create the endpoint. And creating the endpoint means actually provisioning the instances for a persistent endpoint. So when we run AWS create endpoint, that's going to actually go out and spin up those instances, load our model, load our container, and make sure that it's up and ready to be a REST API and serve out predictions from our machine learning model. And so AWS SageMaker create endpoint, all we have to do is define the endpoint name. We'll call it my endpoint, and an endpoint config name, which will point back to that model1 config that we just created in the step above. Well, that's great. Now we've got an endpoint up and running. But a lot of times in machine learning, people want to be able to update their endpoints. They've gotten new data in, they've retrained their model, or they think they've made an improvement in how they've set up their model, whether that's a different algorithm or just better hyperparameters or other values. SageMaker, again, makes that really, really easy for you to do. So we use blue-green deployments, which means you don't have any scheduled downtime. When you update a SageMaker endpoint, you can be sure that you're not going to lose traffic because you have to take your endpoint out of service and then put it back up in service with the new model. Nope, we handle all that behind the scenes for you with a blue-green deployment. You can also deploy multiple models behind the same endpoint. We'll talk a little bit about that in the reduced risk deployment section as well. So to do that updating endpoint operation, it looks very similar to our last block of code. We're going to create a model. In this case, we're going to call it model2. We're going to point at a different model artifact in S3, model2.tar.gz. We're going to create a new endpoint configuration. We're going to call that model2-config, and we'll just point at the model2 model name that we just created in the previous step. But that's the only thing that's different. Now, you could also change some of the hardware configurations. Perhaps you moved from a tree-based method to a neural network, and you want to instead use GPUs in this case rather than CPUs. You can do that. That's fine. In this case, we've just kept 2 ML/M4X large as our endpoint setup. And then instead of using AWS SageMaker create model, we're going to use AWS SageMaker, create endpoint. We're going to use AWS SageMaker update endpoint. And we'll point at that same endpoint name, my endpoint, but we'll use the model2-config instead. And that's all it takes to update. But in a lot of cases, although we may test, your scientist may test on a holdout sample of data, and he may be confident that the model is performing more effectively based on that holdout data set, that may actually not be the case when you scale it out into the real world, or there may still be unforeseen issues that you might run into. And so you probably want to reduce your risk of when you incrementally retrain your model with new data and you want to update that endpoint, or when you try out a new algorithm and you think you've made improvements, you want to reduce the risk of updating that endpoint to switching 100% of the traffic over. So there's a very simple way in SageMaker to do a limited test so that you're still checking how the second model would do in production, but you're not sending all of your traffic there, especially if you have a high-value service that's driving this with very important customers or a lot of financial impact. You want to do these reduced risk deployments, where what we're going to do now is, again, create an endpoint config, but instead of just pointing at one production variant of Model 1 or Model 2, we're going to point at 2 of them, Model 1 and Model 2. And here's where we give them different variant names, Model 1-traffic and Model 2-traffic, so that we can understand which predictions went to which model. We also give them different variant weights. So we give Model 1 95 and Model 2 5. So that means 95% of the traffic is going to go to our tested Model 1 that's already been in production that we're comfortable with, and 5% of the traffic is going to come into that new Model 2 that we want to see how it performs when we actually scale it in the real world. After that, we just do the same update endpoint operation that we just talked about, use that same update endpoint API, and we use the same endpoint name, my endpoint, and point at that both models config that we just created. The next step is to swap the weights. So after we've had Model 2 in production for a while, we've watched the traffic go in, we're confirmed that it's performing as we'd expected, we're comfortable with its behavior, we may want to say, hey, all of a sudden we could just switch the endpoint to using just Model 2, or we could start scaling back and give more traffic to Model 2 and less traffic to Model 1. And the SageMaker makes it very easy to do that as well. So you can do update endpoint weights and capacities. And that API will actually adjust Model 1's weight down to, in this case, 5. So there's a weight of 5 on Model 1, a weight of 5 on Model 2. That means each of them will get 50% of the traffic. And you could continue decrementing Model 1's percent of traffic down further and further and either remove it entirely, or you could actually decide to always keep a little bit of traffic going to Model 1 in case you want to see how Model 1 and Model 2 vary in other future use cases or if one drifts more than the other. So it provides you a lot of flexibility to control traffic and constantly monitor and maintain and make sure that you're comfortable with which model is in production. Now that you've got your endpoint up and running, SageMaker tries to make it very easy to scale that endpoint. So there's a console setting for automatic scaling, and it's very easy to use. You just navigate to your endpoint, take a look at the automatic scaling. You can set the minimum number of instances and the maximum number of instances that you want behind that endpoint. You specify a threshold for target invocations per instance. We recommend using that as the value that you use for your automatic scaling. We find that it does a pretty good job of finding those non-linearities in latency. So it relates pretty well, it maps pretty well to once you find that threshold of invocations. If you go above it, you may see higher latencies, and below it, you'll see the latencies you desire. So trying to figure that precise threshold out takes a little bit of experimentation. You can also set scaling cooldowns. So this is the amount of time that will have to be above the threshold or below the threshold in order to add or remove instances. And this just prevents fluctuation if your traffic is highly volatile. So, I think most people know why automatic scaling is a benefit, but just to reiterate, most traffic is cyclical. You have peaks, maybe it's daily, and you might have peaks when people are awake, and troughs when people are asleep. You may have a trend, so over time you may see more traffic coming to the service as it becomes more popular, and you may also have large single days where you have a spike in traffic because it's a holiday or because of some other unexpected event. And in those cases, you really don't want to sit there and monitor your endpoint and maintain your endpoint, and so automatic scaling makes it much easier. You don't want to provision to the max, because if you provision to the max, then you're overpaying during the times when people are asleep or your times when traffic are down. And you want to still be able to make sure that you have good SLAs and good latencies for prediction, so you don't want to provision to the min either. So automatic scaling allows you to kind of have the best of both worlds in those cases. So what does automatic scaling look like in action? So we have a plot here of a SageMaker endpoint. We've plotted both invocations in total and invocations per instance. We start that endpoint out with just a single instance behind it. We kick off a load test. We send a whole bunch of invocations to that endpoint. It crosses the threshold, past the past the cooldown, and that initiates the auto-scaling component that adds an instance to the endpoint. So you can see at 2135 in that graph, the two lines split. The invocations per instance go down. New instances have been added, so the load balancer starts partitioning out. You keep the same total level of invocations, but invocation per instance goes way down because you now have new instances in your endpoint, and you can better manage your traffic or better respond to your traffic with better latency. Now, we recommend using invocations per instance as the threshold, but we do have customers who have very specific scaling criteria that may not be met by invocations per instance. They may have an algorithm that has very specific memory, CPU, or GPU requirements. And in those cases, SageMaker also allows you to do automatic scaling based on the endpoint's instance's CloudWatch metrics. So what does that look like? So we have to create an application auto-scaling policy. So we use the AWS application auto-scaling CLI, and we say register scalable target. The first thing we do is provide the service name, which is SageMaker. We provide our resource, which is our Model 2 variant, and we provide the scalable dimension. So how many instances in this case, and give it a min and a max amount. Then we provide the actual policy. So we put the scaling policy, we give it a name, Model 2 scaling, we respecify some of that information about the service and the variant, but the real important numbers here are in that target tracking scaling policy configuration. And we define a metric name, CPU utilization, and a target value of 50. So on average, when our instances CPU utilization goes above 50%, we're going to add instances to that endpoint. And we can see what that looks like under a load test. So again, we start off, top plot is invocations and invocations per instance. You can see those are tracking together. We have one instance in the endpoint. We kick off that load test. CPU utilization in total for our endpoint spikes and then plateaus as we've kind of exhausted the limits of our endpoint CPU. And then we have a split in the middle of the chart as the instances come up from auto-scaling. And so that automatic scaling allows us to handle more invocations overall and with fewer invocations per instance. And we get the CPU effectiveness of all those other instances added to the values on the chart so that you can see we're really able to better meet the invocation requests coming in. So with that, I'm going to pass it off to Prasad, who's going to talk us through how SageMaker has been integrated with Intuit.
Hi, everyone. I'm Prasad Prabhu. I'm a principal engineer with Intuit's central data platform. This is what I'm going to talk about today, which is just a brief introduction to Intuit, how we use machine learning, a brief overview of our data lake functional architecture and which parts are served by SageMaker, a typical model development workflow at Intuit, and the key benefits of SageMaker that we've seen, and how we standardized the model development process to get speed. And then a brief demo of the stuff we've built. Right? So Intuit is a financial products company in that we help individuals track their personal finance, do their taxes. We help small businesses do their accounting. We have products for self-employed because gig economy is big nowadays. We have tools used by accountants to manage books for small businesses. Now, across all of these, we've found machine learning has cross-cutting applications. We have a lot of SaaS offerings and mobile offerings. So we have security-based models. We have things around each of the products. So for example, in our tax group, we use machine learning to predict, to personalize the product so that we give the best experience to each user. The US tax code is fairly complex. Machine learning allows us to simplify it for individual users. In the small business group, we use machine learning to help us gather data about these small businesses, automatically scrape their bank accounts, and then kind of sort through which transactions belong to which categories. And in self-employed, we use them for things like trying to differentiate between personal and business expenses to help self-employed folks maximize their returns. Right? So this is like a brief overview of our functional data lake. Right? We have a product that has instrumentation that sends out beacons of the events that are happening. We have a real-time event bus, which is Kafka-based, which all of those events land up in. We have a feature management platform that reads those events, featureizes them, maybe extracts values embedded in a big JSON object, maybe does things like extract business fields out of them, and then stores it in an online feature store. We also have things that read off of the event bus and put it into our data lake for large-scale analytics and machine learning. And then we have data users, which are our analysts and data scientists, use things like SageMaker notebooks and traditional Hive clients to connect to the data lake, run large queries, get this data out. Right? Once you have the data, we have a mechanism to store those models in a model repository after we train them, and then push them out into a REST API model hosting system. We have a control tier, which gives us things like scheduling engine to run batch jobs for either training or model execution, an ML orchestration that helps us track model versioning, and that's one of the parts I'll give a demo about at the end. A service catalog, which gives us standardized implementations of SageMaker resources and other AWS resources, and a data catalog to help us track what data is available where. And the data catalog is also critical because we have a lot of data that's subject to compliance, whether that's tax compliance in the US or GDPR-like requirements across in Europe or in other countries. So the data catalog helps us kind of keep track of what regulation is applicable to which piece of data, who can access it, and things like that. Given the data that we store, which is primarily tax and financial related, we also have a lot of data handling guidelines around who can access the data, maintaining audit trails of who accessed it, who modified it. That was one of the key requirements for us. Right? So a typical model deployment workflow or development workflow looks something like this. It starts off with an analyst or a data scientist finding a gap in our product or finding a place where we can optimize the user interface. And we figure out what are the KPIs that indicate what the problem is and a potential solution of how we can personalize the particular experience flow. Right? Once we have that, our data scientists spin up a SageMaker notebook. They get to wrangle the data. They do data visualization. They play around with different algorithms to see which one fits the use case the best and the nature of the data. Once they have figured that out, a couple of things come out of that process. One thing is which algorithm they want to use, and then another thing is a potentially data transformation job that needs to be run on the data at a regular basis. Right? So I'll talk about the model deployment workflow rather than the ETL process over here. So once somebody's figured out, this is the algorithm I want to use, they'll build a Docker image, and there's a couple of ways they can do it. They can use either one of the SageMaker available default, like out-of-the-box provided algorithms, or they can use other algorithms which might be a combination of open source implementations. And in that case, they'll build their own Docker container. We push that Docker to SageMaker training. Once the training job is run, we have a model artifact. One of the things that we've done is essentially improved the model development lifecycle, and we've brought in the rigor of software development to this workflow. So once the model is trained, we actually want to put it through several phases of testing. We have a dev testing workflow where a data scientist just runs their testing to confirm the model looks okay. Then we put it into a QA environment where we integrate it with these software products, confirm it has access to all of the features that it needs, and the product is behaving the way it should, integrated with the model. We run a whole bunch of performance testing at this point to make sure the model behaves as it needs to at the scale it needs, that is needed. And once everything looks good, we publish the model to production. And the artifact that goes to production is essentially the algorithm or the Docker container to use, the instance sizes, and auto-scaling groups that we need for the traffic, right? And that's kind of what we promote to our production environment. Okay? So the key benefits of Amazon SageMaker, as we've seen them, is this, a lot of algorithms are being supported, and new ones keep getting added all the time. We originally had our own framework, which was more homegrown and built in-house, but it doesn't scale well when you want to keep adding new things. Intuit doesn't want to spend its resources trying to add support for open source things and translating them into our in-house framework. So Amazon building it and providing these Dockers out of the box is a huge advantage. Right? We also have custom algorithms supported using Docker. This was a big win for us because we have a lot of our own internal models, which we are migrating. So in the migration phase, it helps us a lot to have custom support. It's also highly customizable in the type of instances that we run. And when we run our performance testing, we actually find out there's some models which are bound by CPU, some by memory, like they might load a huge lookup table into memory, or some might be I/O bound if they're doing a lot of feature lookup. We can customize which instances to use and customize our auto-scaling groups. This helps us move really, really quickly. And out-of-the-box model hyperparameter tuning. Our data scientists love this feature, right? Another critical thing that we love is security. Given the kind of data that we have, Amazon gives us really good tools and really solid integration with IAM and KMS. So we can do things like when somebody spins up a SageMaker notebook, it's locked down typically to the individual data scientist who spun it up, and nobody else can log in. When they fire queries, we can see and log what queries were fired, right? So all of these are super cool and a good model for authentication and authorization. This is a feature of SageMaker plus another AWS service called KMS, EMR. We use a lot of Hive for our data exploration, and we've figured out that you can actually integrate Hive on EMR with our Active Directory. So when a user logs in, we can track across all these systems which user is doing what action. And obviously, the scalability of Amazon Cloud. When we were in our own data center, one of the biggest bottlenecks was getting time on our Hadoop cluster. So data scientists were always fighting for compute resources. With Amazon, it's much easier for them to go and start experimenting on a data science use case. They're not held back by lack of capacity. Right? So the things that we did to standardize model development, right? We standardized the notebooks, which means standardizing the security model around notebook instances based on the IAM role that's available to it, integration with our Active Directory and Kerberos, and adding functional integrations to Hive and our data marts. So what we did over here is we built a custom Lambda that can be launched through AWS Service Catalog. And when a data scientist wants to get a new instance, they go to Service Catalog, say, give me a new instance. They just need to choose what size they want, and it'll automatically launch it with the IAM role that is assigned to them. So they don't need to do anything extra. They have the permission that they need when the SageMaker notebook comes up. Right? Once the SageMaker notebook has come up, we have custom actions that go in and do things like point SageMaker to our internal PyPy repo. We don't want them going out to the internet. Integration with and establishing trust with our Kerberos instances, and adding monitoring tools behind the scenes so we can monitor that SageMaker instance. For training, we didn't do too much. We have built a Python library that makes it really easy to build Docker images that are used for custom training. Otherwise, we use the out-of-the-box Boto API for launching training jobs. Right? When it comes to hosting, we reuse the Python library I talked about earlier, so that when somebody spins up a new hosting image, we ensure that the hosting image is exactly identical to the training image in terms of having all of the prerequisites installed on board. Most of our data scientists use Python, so that's why we standardized on this approach. And then integration with our internal API gateway and services gateway. By default, when you have a SageMaker hosting instance that comes up, it's actually authenticated and authorized through IAM. Not all of our customers can rely on AWS IAM rules, so we have our own services mesh that handles a lot of these authentication authorization. And then we built a model deployment tool that is kind of a CI/CD tool to enforce a strict model development lifecycle. Right? All of this helped Intuit cut down the time taken to build a new model and deploy to production from something like 6 months to 1 week. That's how easy it's been. So this part, I'm going to give a brief demo of the tools that we built. I'll just talk about the version of models that go into the online hosting world and not the offline batch mode at this point. Right? So we've essentially extended Python's setup.py to provide an additional kind of input to the whole thing. So those of you who are familiar with Python know that there's something called setup.py. And it's a place that a Python developer can declare all of their dependencies when they start building a model. And here you can see there is a section that says install_requires, and there's a bunch of Python dependencies in there. You have Python, pandas, TensorFlow, or if you're using scikit-learn. You can list all of your dependencies over there, and then you need to provide one additional thing over there, which is entry points. And the two things over there are the setup_tools docker.predict, and then the other one is the train. If you look at the Amazon SageMaker documentation, they actually say when they spin up their Docker instance, they invoke a specific entry point on that Docker container. What this allows us to do is provide a mapping from the entry point that SageMaker is looking for to a specific function within this repo where the model, which needs to kick off the specific job, whether it's training or prediction. So the process is essentially a data scientist comes in, forks a model template repo, which starts off with this basic template, and then they can start adding their own code in here. Once they're ready to actually run something, they just need to run Python setup.py train. What that does in the back end is generates a new Docker file and then kicks off a Docker build, which spits out a Docker image ID. Once it's successful, you have to publish that particular Docker image to ECR. Once it's an ECR, then you can use standard SageMaker commands to kick off training jobs or to use it in hosting. So once the data scientist has built their image, they're happy with it, they come into our internal tool that we call DMAC, or Decision Model Automation Console. You see two big sections in there. The top section is for our homegrown older models, and the new ones are for the SageMaker-based models. And you can see there's a whole bunch of different environments that are available and a count of what models are available to the specific data scientist who's logged in. Right? So let's say I'm a data scientist. I've actually built my model, run a training job, and I have a model.tar.gz sitting in S3 location. I'm going to go in and say, create a new endpoint for me. I give this tool the location of the GitHub repo where the model code resides, which branch or tag that needs to be built, and then what's the path where the model artifact lives. Once I say submit, behind the scenes, it kicks off a Jenkins job that's going to pick up the Git repo, run the setup Docker tools to create the image again, and then push it to ECR, and then run SageMaker, then creates a SageMaker hosting endpoint for it, and then links it to this particular ECR image. Once that part happens, it's actually available to our data scientists to promote through different environments. There's 4 standardized environments that we host, where there's a dev, an E2E, a perf, and a prod environment. We give access to our data scientists to promote it all the way till the perf environment, but not production. Production updates are normally reserved for the engineering teams and the operations folks who monitor these models. So once you have your model built, you can publish it to different environments. We also snapshot a copy of the model artifact, and we snapshot all of the performance characteristics of the model, whether they're operational characteristics in terms of latency and time taken to produce a prediction, or the efficacy of the model itself. All of those are captured and linked to the specific version. Every time they retrain, it actually creates a new version of the model itself that you can promote all the way through. At this point, we haven't integrated with SageMaker's ability to create A/B tests, but that's on our roadmap so that you can start creating different versions of the model, set up A/B tests easily. We have a feedback loop that allows us to monitor the efficacy of the models and then switch traffic at runtime. Right. So in conclusion,
thanks, Prasad. Really good stuff. So just to kind of conclude and wrap things up, Amazon SageMaker, as you can see, is a really versatile platform for building, training, and deploying machine learning models at scale. Customers like Intuit have had a lot of success implementing it into their workflows with really impressive results. And you're able to go out and explore SageMaker, which is free tier eligible to build models of your own. And with that, we will take questions. So thank you for attending. Question in the middle there? I don't know if we have mics. I don't see them in the aisle.
I can shout.
Sounds good.
How long did it take you to put the whole workbench together since the time you started? You decided that this is the architecture, this is the infrastructure that we're going to use.
got it. So I think we went incrementally. So SageMaker was announced at last reInvent. We started our development probably soon after that. And then we started building bits around integration with our own internal service mesh. That probably came soon. Then we built setup tools.docker. And then the UI that I showed, we had that from our earlier system that we had built. So we just repurposed it to also work with SageMaker. So we went just like building incrementally. And that took maybe 4 or 5 months.
Yep. Good.
So that's a lot of data scientists who work on that. They essentially look at, are we trying to, like, what's the kind of prediction we're trying to do? Is it a numerical or a regression value? Or maybe it's a more complex prediction? So I'm not as familiar with the data science algorithms myself. David,
Just to add on what Prasad said, right now automatic model tuning supports hyperparameter tuning, but we kind of see there's a lot of space. There's still a lot of research to be done in the auto machine learning space, where you would do things like pick between different algorithms, and that's a space that we're kind of passionate about and thinking about. So it is a problem that we've seen some research papers on, but it's still an active area of development. So for right now, what a lot of scientists do is they get to the domain, they use some heuristics to understand which algorithms might be good, and then they test them. And with SageMaker's ability to spin up managed training jobs in parallel, it really enables that testing in a very quick, efficient way. Where you kick off multiple jobs at once to test lots of different algorithms against one another on the same problem. Other question?
Yeah. May I know what technology you use to build up your data lake and what's the size of the data lake?
So in terms of size, we probably have somewhere between 1 and 2 petabytes, I think. We have, in terms of sources, it's a lot, probably more than 100. From different types of sources. And then in terms of user base, we might have around a few hundred users across our analyst and data science community. In terms of our technology stack, we use a lot of Scoop and other open source ingestion tools. We have some tools that are built in-house as well. Once we have ingested the data, we have a lot of processing that happens using traditional MapReduce, Spark, just regular Python jobs for smaller data sets, or loading into something like an Oracle or a Vertica and then running transformation SQLs on those. And a lot of data that's available for exploration is made available through Hive as the primary query engine. And there's also Vertica that's used heavily within our company.
Another question right there?
Mm-hmm. 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 So just to understand, the question is around how we added like custom. Okay. So once we have the instance that's spun up, it's actually available as a REST endpoint. This is available in the open source Jupyter world as well. You can invoke Jupyter to run custom scripts. So what we do is once the instance is booted up, it actually emits lifecycle phases to say it's now ready or it's being booted up. Once we detect it's ready, we have a custom step that runs on it. It downloads the artifacts that we need off of a S3 bucket where these artifacts are stored, and then runs those scripts to install our monitoring agent or modifying Kerberos config files. That's how we do it. Docker image during the hosting phase, or? Mm-hmm. Got it. So for the training jobs itself, we don't particularly have anything running within the Docker image in terms of authorization and security, because when a training job is running, it's virtually inaccessible to the outside world. There's no REST endpoint that can reach it. So we just let it run up and then spin down. The only thing that can execute on the particular Docker image is stuff that gets executed. So we do have static monitoring tools that kind of run a scan on the Docker image to confirm there's nothing malicious embedded inside the container itself. There's a question. Oh, sorry. Mm-hmm. Got it. So we have a very thin layer of UI that you saw. And then behind the scenes, a lot of the heavy lifting is done using Jenkins, because Jenkins provides a lot of the tools by default, like monitoring GitHub repos, pulling them down, running something on them, and then pushing to ECR. We run the Jenkins images in AWS, so that makes it easy to give it permissions to push to ECR or execute commands in SageMaker to create endpoints and things like that. So Jenkins is the primary heavy lifter of the CI/CD pipeline. Not particularly, because Jenkins is pretty powerful and flexible. Like wherever we don't find plugins, we can always run a shell script to do what we need to do.
And just to add to that, we have a couple of GitHub repositories in AWS that actually are on CI/CD pipelines. So Sage Build is one of them. And so that's in the AWS samples repository, I believe. And that kind of sets up that has a CloudFormation template that would set up something to use code commit and code deploy that will allow you to kind of have your own CI/CD pipeline within SageMaker. That's 100% AWS. But we also see a lot of customers using things like Jenkins and other external tools. So it's really more about what works for your specific business.
To add in case of like Jenkins, it integrates with our other enterprise tools, which help in like scanning and monitoring builds and stuff like that. Mm-hmm. Yep, those are all those are SageMaker environments. So what we do is if a data scientist comes in and says, I want to create model A, and I'm publishing this to a particular, let's say, dev environment, what we do is we've templatized the endpoint name to say, there's the endpoint name that the data scientist actually chose, appended with a version number, and append the environment to it. So what gets spun up in AWS is actually my endpoint -0.1-dev. Right? So So, yep. So that's another thing that we do behind the scenes to help us manage those versions. That's right. That's right. So we have, I think the functional tests are all automated at this point. We are in the process of automating the performance tests. Today, the performance tests are run manually, and then our perf engineers look at the results. They talk to the product team, which is integrating with the particular model to see, is the latency good enough? We also rely a lot on CloudWatch metrics, because CloudWatch gives us exactly what was the overhead added by, like SageMaker has a very thin network layer in between, and then the time taken by our Docker container and the model code itself. So we know what needs to be tuned. We also get logs printed out from a Docker container. I think they show up as CloudWatch logs as well. So we can instrument inside the Docker container a little bit to see what's happening and give us clues on optimizing them.
I think we had another question here. Yeah. Yeah, so we just launched a model search functionality right before Thanksgiving, actually. And so you can tag your models using AWS tags, and that's how we see a lot of people trying to track their provenance of which data sets were used, which training jobs created this model. And so this model search functionality is in beta. It's in the console, so if you go to the AWS SageMaker console and click search, you can see your past training jobs and models and understand some provenance there.
Yeah. Okay. So that's a good question. I didn't cover it in the slides. The setup-tools.docker is made available as a Python library. So you can just, when you start up your environment, you'll say pip install setup-tools.docker, and then that's available in your local Python repository. And then you can start opening it up and then adding things on top of it. And we publish that to our own internal PyPy repository. So it's available to all data scientists, similar to how in the Java world you have a Nexus repository that all the libraries are available. You can just pull that in and then start using it. Yeah. Mm-hmm. Yeah. No, like data wrangling is its own problem. This is for use cases where we already had data available, and we just had to, like earlier we were constrained by hardware resources, or training jobs would take too long to run, things like that. So with SageMaker, there's three parts to it, right? There's notebooks, the algorithms, and hosting. So the notebooks there wasn't too much of a learning curve because Jupyter is a fairly well-established notebook that's available in the open source community. So that was pretty what took longer was for them to learn how to use our tools to actually launch those, and then how to integrate with our existing data sources, because it's a little bit different than how they used to do it in our data center versus in AWS. So that was the learning curve. In terms of the algorithms, I think a lot of the algorithms are available in the open source. So Amazon provides fairly decent documentation on how to use it. So that was manageable too. Hosting, we don't expose to our data scientists too much. Our engineering teams tend to take care of those things, engineering and operations.
Just to add to that, we do have some ways to get up and running with SageMaker. When you stand up a SageMaker notebook instance, it's pre-populated with a bunch of example notebooks that walk you through, kind of get you started. You know, now that it's been around for a year, we've got some good blog content out there that talks about how to do a variety of things in SageMaker, and the ML certification that we just announced could be another way that you can learn more about that kind of thing. All right, I think I'll be staying around for a few more minutes, but our time is up, so we'll leave the stage now, but we'll be around in case you do have additional questions. Thank you, guys.
Thank you.